Hey everybody, Shawn here from the Automation Blog and School, and in this episode of the Automation Podcast, I meet up with Gary Pratt of ControlSphere to get a detailed look inside of his brand new book, the Book of Codesys. Gary, thank you for coming on the Automation Podcast. I'm really looking forward to learning all about the Book of Codesys, and I want to thank you for sending in a review copy for us to take a look at and dig through. But I'm excited to have you on the podcast to learn a little bit about yourself and what drove you to write this book and about the book itself. I know you prepared to kind of go through the book and talk about how it not only deals with Codesys, but 61131-3. So before we actually jump into your presentation, would you mind just telling the audience a little bit about who you are?
Absolutely, and thank you, Shawn, for having me on. As Shawn said, I'm Gary Pratt, president of ControlSphere Engineering, my own little one-man band company. That's a little bit about my background. I began my professional career in 1982 at Chevron Corporate Engineering in downtown San Francisco. That was quite an experience, an eye-opener for a young kid from rural Wisconsin. My first job there, interestingly enough, was to build a control system for a mining operation. And the plant operators were promoted up from the mine. And so they did not want to have any of that fancy computer-controlled stuff. They wanted relays and timers. So we built a control system, thousands of relays, timers, taking up, a wall of these relays and timers. So I figure I'm probably one of the few people left in the industry that has actually written ladder logic and implemented in relays and timers. I was so concerned about race condition that I'd written a simulator in a CPM computer in BASIC that simulated the whole system. And people probably have no idea what a race condition is because in computer controls, everything's done sequentially, but in relays, everything happens simultaneously, and you could potentially have a race condition. And I did find one and fixed one. And my second job there was a shale oil research project, and that did use those fancy new electronic controllers. So that was my first experience with PLC hardware. Anyway, from there, my career kind of meandered a bit. I moved to Dallas and moved into a PC board, circuit board electronics design for high-power electronics with complex feedback control. And then I made my way into FPGA designs for medical imaging, and which eventually found myself working with GE Medical in Milwaukee. And from there, GE Fanuc found out that I had a background in controls, and they recruited me to help with their gas turbine engine control project. That was for GE, actually it's for GE Oil and Gas, based in Florence, Italy. That was a tough job, but somebody's got to do it. Somebody has to learn to appreciate Chianti, right? But then I moved on to a job that helped other GE entities adapt GE control systems. And my first encounter with Codesys occurred at the GE Research in Munich, where a young man had built a water pilot project using controls from a hardware that used Codesys. And he showed me this his design, and I saw this wonderful language, well-structured code in this really nice environment, and man, I thought I died and went to heaven. It was some of the best code and language development system that I had encountered. And since, I probably over my career used many dozens, maybe even 100 of development environments and languages, and Codesys and IEC 61131-3 are one of my favorites. Anyway, through some serendipity, I ended up joining a PLC company that had hardware based on Codesys. That's Bedrock Automation. There, we took some Codesys training from a company in Minnesota, and didn't get what we needed. We had Germany come over and deliver the training that they had at the time. We didn't think that was really going to be appropriate for our North American office. So the leadership tasked me with coming up with our own training, and they gave me 2 whole months to do it. So I had myself and a team of a couple young, capable engineers Spent those 2 months and many 70-hour work weeks and put together the first draft of the training the way that we wanted it, just in time for the product release, and the training was well received. And fortunately, when I left Bedrock, they were generous enough to allow me to take the training with me. So that was actually the genesis of the Codesys intensive training and the Book of Codesys that we're going to talk about today. The content has changed significantly over the years and have been enhanced and so forth, but it always has its roots in Bedrock automation, and I appreciate them for allowing that to happen. From there, through some more serendipity, I found myself establishing the Codesys Corporation of North American office. And after that, getting that up and running, I turned it over to the very capable team that's running the organization now. I do, however, continue to deliver their advanced training for them. And through these training sessions, I've been able to continue to refine and perfect the training. Basically, I consider every question a student asks or a mistake that they make during the lab to be a reflection of my training and an opportunity to improve the training. So I credit that feedback for the quality of the training and the overwhelmingly positive feedback the training receives today. However, I had always wanted that body of work to benefit a wider audience, not just the students in the half dozen or dozen classes I taught a year. And then COVID hit, and the opportunity actually presented itself. So basically, I took pretty much a year and a half off from work and dedicated, 50, 60 hours a week to converting that training into a book. Now I know why it's said that if prospective authors knew how much time it took to write a book, that there would be no books or no authors. It was a massive undertaking, way more than I ever expected it to be. Between my wife and I, my wife was my primary editor, we figure we probably have about 2,500 hours into writing this book. Anyway, I think it's worth it. Hope readers do. And so far, it's getting rave reviews on Amazon. Perfect 5 out of 5 stars. It's really the training that I would have wanted to have when I first started using Codesys some 10 years ago or so. So we finally finished the book in December of 2021, and got it published, but then I began my education on how to be a publisher and a retailer. And I've got a lot more stories on that front to tell, but fortunately we don't have time for that today, but I'll cover that some other time. So let's talk about the book a little. As I mentioned, it was published in December of 2021. Some people tell me, let me turn my laser pointer on here. I'm an engineer, I have to point at things. Some people tell me that it should have been titled, it's the Book of Codesys, but it should have been the Big Book of Codesys, or maybe the Huge Book of Codesys, as our former president would have said. It's 8.5 by, it's hardcover, 8.5 by 11 inches, over 1.5 inches thick, over 4 pounds, and has 492 full color pages of the highest quality paper and color ink that I can buy. I mean, it's rather expensive, but it needs that level of fine resolution and color to be able to see the screenshots clearly. So that's what we got right now. If you want to learn more about the Book of Codesys, you can go to bookofcodesys.com. This is a bulletin board that contains forums with sample chapters from the book, so you can see its depth and breadth and level of detail. It contains a sample of a typical lab, the detailed table of contents, so you can see exactly what material is covered in each chapters to see if it's right for you, and covers how to purchase the book. Most chapters end with a structured or unstructured lab. There's also a forum where you can download the starting point for these labs. The book is only available in printed form. I've been told that the minute a book is released in electronic form, that its security is defeated and it basically becomes public domain. So with the time invested in this book, I'm sure you can understand why I'm reluctant to let that happen. But I do provide a full text search here of the book to mitigate that one drawback to a paper book. So the forum contains a search tool there that will provide a page number for any 1, 2, or 3 word search. And then finally, for those of you who learn better with a human interaction, there's also a forum which discusses the training opportunities. So basically, these include the Codesys Intensive Training Course. Just go to the Codesys US website to find out more about those. There's actually one of those next week in Boston. I think there's a couple seats left if anyone's interested. There's an online version in May, and I think there's going to be one in either Wisconsin or Minnesota in July. Another option is I'm available for private training if you have enough students or urgent enough need to justify that. And I'm also trying something new, which I call accelerated training. In this training, students read 5 chapters per day, and then we get together for 2 hours each day to discuss the chapters in the labs, and then they are assigned the homework for the next 5 chapters in labs. So it's a much lower cost option that still gives some level of human interaction and the ability to ask questions and have some discussions. Okay, so anyway, I'm actually going to go through every chapter and talk about each one, but I want just to show you the table of contents here so you can see it's 25 chapters and more or less some introduction, all the languages, and then some of the other features, and then there's a final project at the end. Oh, and then lurking over here in the corner is Roland Wagner he's in Codesys in Germany. Roland is one of my biggest cheerleaders, and he actually played a big role in providing the encouragement and support during the book writing process, so I appreciate his enthusiasm. And as you can see here, Roland is as pleased with the results as I am, and I hope you are. Anyway, so I know your viewers may have seen this graphic from the interview with Marcus at the Codesys North America, the interview you did a few weeks back. But I think it's important enough to repeat just in case. This really shows how popular Codesys has become in Europe. For those on audio only, this graphic is from a 2011 survey performed by the Computer and Automation magazine and 2 German universities, showing the relative popularity of PLC development systems in Germany. It shows Siemens at 35% and Codesys and systems based on Codesys, in this case Beckhoff and Bosch, also adding up to 35%. It also shows B&R at 16% and Rockwell at 7% and other at 7%. So even back in 2011, Codesys had caught up to the big dog in its backyard. And Codesys has really caught on fire in Europe, and it's really doing the same in North America. Marcus also showed this slide, but I want to cover it in a little more detail. For those on audio only, this graphic shows the entire Codesys ecosystem, which is actually made up of 2 distinct and separate software packages developed by 2 different groups in Germany, same campus. The IDE is shown in the upper left quadrant of this graphic, and that's developed in C++. And the runtime, which takes up basically the remainder of the graphic, and it's developed in C. So the IDE is downloaded from the Codesys store. It's completely free of charge. You have to have a sign up, but don't worry, they don't spam you or share your private information or anything. It's a very safe thing to do, and it also uninstalls pretty clean. So it's a fairly safe thing to download and give it a try. It does take a while to install. It's a sizable piece of software. The store has lots of libraries and examples that you can get. You can get some different online trainings or sign up for different trainings from the Codesys store, and that all goes in develop your code. After the code has been developed, you connect to a runtime, and that triggers a series of events which includes compiling and downloading the machine code. And I should note that the Codesys code is compiled, which generates code that is extremely fast and very compact, much more than many of the competitors who use interpreted code. And actually, Codesys develops their own compilers. I mean, the easy way out would be to use just the GNU compiler or something like that, but they develop their own, and the reason they do that is first they can do lots of optimizations for specific for PLCs, but probably more important is that they are then able to build in a lot of really cool debugging features, which we'll talk about later on. Anyway, the runtime can be installed on the target hardware in 2 different ways. One is you can purchase in what's called a single license and install it on your hardware. Or the second is purchase a runtime toolkit, integrate it in with your tool chain, and put it on your hardware. So that first route is used more often by end users. There are SL runtimes available for a wide variety of platforms, including any x86 hardware running Windows or Linux, or ARM running Windows, or Raspberry Pi, and many others. And there's in fact some runtimes for hardware that uses other development environments and competing development environments for people who want to use Codesys instead of what normally comes with their hardware. Many of these SLs have a 2-hour demo that'll run for 2 hours at a time, so you can get that, put it on your Raspberry Pi, and run Codesys for a couple hours at a time if you want, and then just restart it after that. Now, the second route is these are for OEMs that want to put Codesys on their hardware and then sell it. So they do this by purchasing the runtime toolkit, adding whatever code is necessary. This comes with the frame of the runtime, which is a bunch of stubs, and then they have to fill out those stubs. How do you get to the real-time operating system, if there is an operating system? This will actually run on bare hardware too. You don't have to have an operating system underneath if you don't want to. How do you get to the Ethernet ports and things like that? So they have to add all that, and then they install it on their hardware. That's it. The runtime has support for target visualization, which is locally connected visualization. It also has a built-in web server to serve up web pages to any browser through any type of network. It has OPCOA and MQTT to get out to the outside world, as well as connections for AWS and Azure and Google Cloud. As well as Codesys has its own automation server with lots of cool features. It'll actually detect and dispatch service personnel out to the field. The system has provisions for safety. It can be designed with a safety system, SIL 2 or SIL 3. A lot of enhancements for motion. And it also will handle just about any field bus out there. Any local I/O, the hardware vendors can create and support their own local I/O, as well as pretty much any field bus protocol over pretty much any field bus network. So the way Codesys implements the runtime makes it extremely easy for hardware vendors to supply Codesys on their hardware. They can often get Codesys up and running in a couple of weeks. It's perfectly designed to finally bring platform independence to the controls industry. And actually, I see a lot of parallels to the 1980s and the 2000s. So who remembers Wang or Commodore or Digital or Altair or Sun or Xerox or Radio Shack or Processor Technology? Those were all PC vendors in the 1970s and 80s. Who remembers HP and Dell, Toshiba, Sharp, IBM, and NEC? Well, that first group are the PC vendors who chose to stay with their platform-dependent operating system. And the second group, the one that we recognize, are the PC hardware vendors who chose to adopt platform-independent operating system, primarily DOS and Windows. So back in the old days, your software was stuck on one PC. It couldn't be moved to other PCs from any other vendor, and you couldn't share data between the two either. They're each their own little island. So fast forward 20 years to the smartphone industry. So who currently uses smartphones from Nokia or Ericsson or Siemens Mobile or BlackBerry, right? Versus who uses phones from LG or Samsung or Google. Of course, so that first group are the smartphone vendors who chose to stay with their platform-dependent proprietary operating system. And the second group are the smartphone vendors who chose to adopt a platform-independent operating system. So, are you seeing a pattern here, right? Industrial controls engineers are demanding the ability to move their application to best-in-class hardware. If you think about it, it's been a long time, or a real long time, since the PLC could be adequately programmed with a simple ladder logic editor. Today's programs are large and complex and require a highly capable development and runtime environment. It just doesn't make sense for every hardware vendor to duplicate the effort to create and maintain a world-class industrial controls development environment. The only long-term solution is the same consolidation that took place in the PC and mobile phone industries. I'm sure that's what's going to happen in our industry as well. So, just like the investment in learning DOS and Windows back in their 80s paid off, and learning Android in the 2000s paid off, I believe the investment in learning Codesys will be time very well spent. And I'm confident history will repeat itself, and Codesys will become the next Microsoft or Android of the industrial controls world. So let's talk a little bit more about the IDE. So Codesys v3 was released in 2006 and was developed from the ground up. Unlike many of its competitors, it's based on the latest software development technology, similar to Microsoft Developer Studio or Eclipse, and it isn't held back by requirements to maintain compatibility with older PLC code and older PLC coding techniques. Because it's based on the latest software and development standard, it's well designed, relatively easy to learn, and easy to use. And it has the best support I've seen for all the IEC 61131-3 languages. Plus, it has its own block-based language called CFC, which you can kind of consider a FBD on steroids. But perhaps the best feature of Codesys in the IDE is that it's totally free of charge. And this is a full-featured tool. It's not defeatured or limited in any way. It's the same IDE I use to develop code. And furthermore, the installation includes a complete runtime, which runs on your laptop for 2 hours at a time. It's the same runtime that runs on any PLCs or single licenses, SLs, that you can buy off the store. Same runtime, same type of performance, everything's the same. And because the IDE is just as good at developing simulation code as it is control code, you can develop your applications, develop your HMI screens, develop your simulation code, and test your entire system without spending a penny. And you can even do that at 40,000 feet on an airplane next business trip, all without spending a penny, all on your laptop. And even further, since you're running the code on the same runtime that will be used in your final target hardware, you can even connect your laptop Ethernet port up to your field I/O and run your equipment or factory directly from your laptop. Now, I would caution against using Windows to run a factory, but it certainly could be done. And I should mention that Codesys actually does offer a real-time version of the runtime, which installs deeper inside the Windows operating system and communicates directly with the hardware. So it makes it much more deterministic. So you could run a factory with that if you wanted. As I mentioned before, the book is derived from the Codesys Intensive Training course. So the graphic on the left here shows a typical slide from the training course, and the picture on the right shows how that looks in the book. It's basically, most of the graphics embedded inside all the verbiage that I would normally speak to when I'm doing a live training. So if you like reading, the book is a great training resource. If you prefer interactive learning, the book is still a great resource to use during the training, just so you don't have to take as many notes, and then obviously to refer back to after the training. And remember, it's got that full text search, so you can also use it as a reference book. So the first few chapters of the book talk about the Codesys company, the Codesys software ecosystem, the basics of the IDE and IEC 61131-3, and also 61131-3 data types. The next chapters cover the 61131-3 languages, which we'll talk about on the next slides. And by the way, the book is a great resource for learning 61131-3 languages, even if you aren't going to use them with Codesys. And by the way, the training slides are available to qualified educators who want to do their own training. So just get a hold of me and I'll let you know how you can obtain those slides. So let's talk about the languages. So for the audio-only group, this slide shows various combinations of office productivity tools and office tasks, and also some lawn care tools and some lawn care tasks that are mismatched. So, who's heard the joke, heaven is where the police are British, the cooks are French, and the engineers are German, the lovers are Italian, and everything else is organized by the Swiss, and hell is where the police are German, the cooks are British, the engineers are French, the lovers are Swiss, and everything else is organized by the Italians. Well, a similar analogy can be made with office productivity tools. Heaven is where documents are created in Word, presentations in PowerPoint, and spreadsheets in Excel. Hell would be where presentations are made in Excel, documents in PowerPoint, and presentations in Word. Or when it comes down to power tools, hell is trying to mow your lawn with a hedge trimmer, or double hell is where you might actually end up is if you try to trim your hedges with a lawnmower. So that's best left to the crazy YouTubers. Don't try that at home. It's certainly possible to make any of these examples of hell work. You certainly can do Excel spreadsheets in Word or PowerPoint, but is it really worth it? Is it worth going to all the effort to learn those tricks to force fit something that's really not meant to be used for that purpose? I know in North America it's been really common to do all the programming in one language, but it's quite a learning curve to learn all the tricks that are necessary to do everything in one language. It's funny, I know the one on LinkedIn, there's a fellow that often puts up how to do things in ladder logic, and he'll have a flow chart of what the functionality that needs to be carried out, and then he shows how to do it in ladder logic. And every time I see that, I think to myself, well, you got this great flow chart. Why don't you just implement it in SFC and be done with it? Obviously he feels that flowchart is the best way to convey the information, right? That's why he uses that to describe what he's going to implement in ladder logic. Why go to that extra step of implementing the ladder logic and making it much less understandable? Just implement it in the flowchart, in SFC in that case. Anyway, sorry, I'll get off my soapbox here and get back onto the presentation. 61131-3 provides us with a very powerful suite of tools. And in my opinion, our job is to learn where best to use them, and that's what this training does. So Codesys, 61131, and my book are all very language agnostic. So the book goes through all the strengths and weaknesses of all the language, and Codesys implements them all just fine. So if you want to choose one language and do everything in one language, you can certainly do that. All right, so the joke goes, the great thing about standards is there are so many to choose from, right? Well, and that's meant to be sarcasm, but in the case of 61131-3, it's really actually an advantage to have several languages from which to choose. So a lot of my students will come into the class and they'll say, I want to specialize in a language. Which language is best? So my usual response is by asking them, well, what's the best number in the Arabic Hindu number system? Or what's the best word in the English language? Now, I've been told that the answer to that last one is spork, but I'm not sure. Shawn, I don't know if you'd agree with that one or not, but we'll discuss that later. Anyway, so Codesys supports all the 61131-3 languages: ladder logic, sequential function chart, structured text, and function block diagram. And it also instruction list, but that's not recommended for new designs. And it also includes the bonus language I mentioned earlier, continuous function chart, which you can really consider it function block diagram on steroid. It's a better version, in my opinion, of function block diagram. Some people still like function block diagram. They like the fact that everything has to be real regimented. I prefer the flexibility that you get with continuous function chart. But we go into more detail on that in the book and in the training. So then the first chapter on language covers ladder logic. It's a great language for what it was originally meant for, complex Boolean logic. So staying within this realm, ladder logic's easy to learn, simple to use, and so forth. This graphic illustrates a point by showing the same Boolean in several different 61131 languages. So, if we're expecting inspect to be true, in ladder logic, it's real easy to see why it's not true. You just follow the blue lines. So for those of you in audio-only land, so I've got a ladder diagram here with several rungs in it. The coil isn't true; is not activated, and you can just follow the activated contacts until you see the one that's not activated. And it's real easy to tell why inspect isn't true. In this case, gantry is right is false. You can do the same thing in CFC or function block diagram, either one. It's not quite as easy as you have to evaluate the ands and ors in your head, but it's still quite doable. So if you prefer not to use ladder logic, these are certainly some alternatives. And then structured text is just downright difficult. It's just not a great language for complex Boolean. Now, we could break this out, put a whole bunch of intermediate variables in, make it a little bit easier, but I guarantee you, even if we did that and we took two people and who could figure out why inspect is false first, I can almost guarantee you the people looking at the ladder logic will find that quicker. So this chapter covers a brief overview and a perspective of the 61131 languages. It provides a brief history of the ladder diagram, describes where LDs and function block diagram are most effectively applied, and goes through the menus and design techniques for LD and FBD. The lab is designing a traffic light in LD and doing some mathematical operations in FBD. And then it also talks about the auto-declare feature, which is a really great tool that Codesys offers for helping you declare your variables. All right, so the next chapter covers sequential function chart. So it emphasizes that anytime you have a set coil or a seal in logic or Boolean flags that impact your code, you really have a state machine, and you should use state machine coding techniques. And it talks about what state machine coding techniques are. And SFC is actually the easiest language to implement the state machine techniques. SFC is easy to design, described your system, and it can be in. So here we got it. This is what it looks like when you're online. It shows you what states your system is in. You can tell what it needs to go on to the next state. This one's waiting for elevator loaded PE to become true, or you can tell you why it's stuck. And it's going to tell you where it's going to go after that next input is satisfied. It's going to go to barrel at elevator state and so forth. So it's very easy, and here we've got some parallel branches, and it just makes it so much easier to understand. And it also makes it easier to debug, and it promotes well-conceived and well-organized designs, because you've handled all the eventualities. You're not going to get a call at midnight on Christmas Eve because your plant shut down because something happened that you forgot to deal with in your other type of code. In SFC, you've dealt with everything, and it makes it really easy to test. You just print it out, go through your test procedures, check off every branch and every step as you exercise it, and when you're done, you're done when every branch and every step have been crossed off. So I like it for that. And then it goes through everything that you need to know about SFC. Here's a typical slide on structured text. ST is basically good for everything else the other languages aren't. It's great for iterating through loops, using whiles or fors or whatever. Now, you can iterate loops in ladder logic. It is possible, but nobody's going to ever understand what you did. So why not just do it in structured text, where at least people have a chance of understanding what it is you did. It's great for complex conditionals, if then else, and case statements. Great for bit manipulations and ands and ors. Again, you can do that in ladder logic, but nobody's going to understand that. String manipulation. You can do state machines in structured text if you follow the discipline, which that is all covered in the chapter, how to write proper state machines in structured text. And it's good for full-blown object-oriented programming, which we'll talk about later on. The next chapter covers all the great debugging features Codesys offers. So these include, information about the runtime file system, the built-in simulator, simple and complex breakpoints. You can really get some granularity on these breakpoints, how you can single step through your code, how the watch list works, how the process cycle impacts your watch list. This great new feature called flow control, which we're showing on the slide here, how to do cross references and call trees, how to do view the device log, how to send your own messages to the device log, how to do an online change, and so forth and so on. Like I said, Codesys has tons of great debugging features. I'd use it just for that. So the next chapter covers POUs, Program Organization Units. That's IEC language for programs, functions, and function blocks. So it describes what all those three things are, when you want to use one over the other. Now, we're all familiar with programs. We've been using those forever. We got functions later on. Most of us have been using those for quite some time. So it doesn't spend a lot of time on those. it does spend a lot of time on function blocks because that's new to many people. And as you can see from this slide, again, I like to use lots of analogies. I think that really helps people understand the concept. And so here, this one I'm actually using my favorite automobile of all time, the 1964 Ford Mustang. So continuous function chart. So we saved this one until this point in the book because CFC is really the best language for combining all the other languages, meaning for putting blocks of other languages together. So CFC is a bonus language provided by Codesys. It's a superset, as I mentioned earlier, superset of function block diagram. I use it instead of function block diagram. And so CFC is best. It has two primary features. One is block-based design, so again, the replacement for function block diagram, or, and maybe even more importantly, for block diagrams. And this is for creating a design of your plant that matches the structure of your plant. So, due to its graphical nature, CFC is easy to understand, and because it's graphical, it's well accepted by plant technicians that are, accustomed to ladder logic. The control can be designed to look like a block diagram of the physical plant. So anyone who knows the physical plant can easily understand and navigate the control design. Plant operators and maintenance personnel can really quickly understand the big picture and the underlying detail to quickly diagnose any problems. In fact, I used to when I was doing demos working for Bedrock, I'd have a hierarchical design of the plant. I would go in and break something, and I would turn the laptop over to the technician in the room, and I'd say, I'd have to say, so here's this code. So all you need to do is double click on a block, and it'll take you into that level. And I'll tell them, okay, your motor 3 in your wastewater treatment plant isn't running. Can you figure out why? And so they look at the block diagram and okay, well I got a wastewater section here. I bet you it's in there. So he'd double click on that, it'd open up and he'd have some blocks and he'd say then there'd be a block that says motors, and I said, well, I bet you it's in there. He'd double click on that. And then inside that he'd find motor 3. And he could see that the input told it to run, but the output it wasn't running. So he'd double click on that, and then you'd see right away, somebody overrode the input from the HMI, and it'd be really easy to fix and diagnose. So the next chapter combines everything learned so far and describes a new programming paradigm that is only possible with the features provided by Codesys and 61131-3. I call this technique object-oriented industrial programming. I do that to differentiate it from the traditional, and sometimes some would say much more complicated and much more dangerous, object-oriented programming. So OOIP is a subset of OOP, and it provides most of the benefits of OOP without all the complexity and reliability issues with OOP. So if you're a traditional programmer, and you want to get your feet wet in object-oriented programming, without hopefully drowning, I would recommend this chapter. And actually, this chapter is the sample chapter that I talked about earlier. So you can go to the Book of Codesys, download the sample, and you have this chapter. So even if you don't purchase the book, you can take a look at this chapter and decide if it's if this type of programming is something that you really want to do. And I'll talk about a video later on also about this technique that I highly recommend. So, your plant is made up of objects, level sensors, mixers, motors for pumps, valves, and so forth. So your plant is made up of objects. There's no reason your control design shouldn't be made up of objects as well. And there's no reason those objects can't match so that if you understand your plant, you understand your control. So notice here that there's a one-to-one correspondence between, so here we got a pressure sensor, here we got a pressure sensor object. Here we got a horsepower sensor, we have a horsepower sensor object. Same with a temperature sensor, level sensor. So we've got 4 sensors in our design, we've got 4 sensor blocks in our control design. Likewise, we've got 2 motors and 2 valves. We have 2 motors objects and 2 valve objects. And these are fully self-contained objects that do everything that's necessary. The analogy I use, it's like the engine in your car. You don't have to know how an engine works. You just have to know how the interfaces work. Same thing with this variable speed drive block. You just drop it down, tell it to run, configure it, which is covered in that video. I'm not going to talk about that today, but that's all covered in that video. I want you to look at later. And you're done. You're done. Well, sorry, you're not done. You still got to do the control block, but at least you don't. All the rest of the complexity is taken out. And if you understand, again, if you understand your physical plant, you're going to understand your control. And I actually see the day coming when these drive manufacturers will provide the control block for you. Right? I've got a forum that we'll talk about later on for sharing these kind of things. But eventually, I think you're going to get a motor, and along with it will come a USB drive or whatever, thumb drive or whatever the technology is then, with a control block for it. The lab for this chapter actually contains several OOIP design examples. One is a discrete design of a bunch of conveyors and pushers and lifters. Another one is a batch design with several augers that auger in a certain amount of material into a vat. And then there's one on a continuous process where the augers are actually driven by variable speed motors, and they vary with speed depending on the flow rate coming into the tank. And there's an outlet pump that varies the speed to keep the tank level constant. And that has a whole bunch of PIDs. It also has a control loop analyzer block that you can use to determine where the poles and zeros are of your loop. And that's free. That's available in the starting labs, and it all comes with it. So the next chapter is for user-defined types, or DUTs, as they say in 61131-3. The chapter covers single and multiple dimensional arrays, structures, unions, and enumerations. And again, I like to use lots of graphics and analogies to make the concepts easier to understand. So for those of you in the audio-only audience, this is a slide on enumerations, and it has two pictures of a inmate. One picture has the normal numbers on the front, his numbers, and the next picture has his name. So enumerations is putting a number with a name. This name happens to be Alex, who happens to be the manager of the training for Codesys North America. And actually, I learned the hard way once that I shouldn't have ever given him the URL for the shared drive where these are at, because I was presenting one day and I popped up this slide and it said Gary on it. So won't do that again. The next chapter is on tasks. So Codesys is a real-time multitasking preemptive operating system. This chapter shows you how to use all its features, how to assign programs to tasks, how to set task priorities, how those priorities affect when the task will run, how to set the watchdog timer time, and how to set up and react to system events. The next chapter is on I/O. This is just an overview of I/O. As you know, I/O is very hardware dependent, so you really got to rely on your hardware vendor to tell you how to use their I/O. But it does include a sample of local I/O, and it also includes a sample of a couple of field buses. And the lab for this is actually creating a field bus master and creating a field bus slave, turning on 2 instances of the runtime, and having them communicate with each other. The next chapter covers libraries. It begins by showing how to use some of the ton of libraries that Codesys provides on the Codesys store. And then the second half of the chapter is how to create your own libraries and revision control within those libraries and things like that. The next chapter is on visualization. So Codesys offers a built-in visualization which is fully integrated into and uses the same look and feel as a control design. So it makes it very easy to do. It also has a concept of what's called a visualization block, which is very similar to a function block. So if you have a visualization blocks that match your function blocks, it makes it really easy to connect the two together. In fact, if you make your visualization hierarchy match the control hierarchy, you can actually connect them all together with one connection. There may be tens of thousands of connections between the two, and you can connect them all together with one single connection at the top level. I mean, it just doesn't get much easier than that. Next, we talk about how to share information with the outside world. There are different ways to do that, and the strengths and weaknesses, we describe the strengths and weaknesses of each of those. OPCUA, OPCUA pub sub, which is like MQTT, and several other techniques for connecting controllers together and sharing data from controllers to the outside world, to MES systems or other HMIs or what have you. The next chapter is on Codesys security. Codesys has 5 different areas of security, and we talk about each one of those, why you'd want to do it, and so forth. The next chapter is on persistence. This is how you store data for the long term in non-volatile memory. There are 34 different ways to do that, which each have their own advantages and disadvantages. We talk about each of those and where each one is best used and how to use it. Then there's actually an entire chapter on a great debugging tool called Trace, which is basically a digital oscilloscope that runs on the target hardware and captures the data, regardless of the speed of the controller. It's not uploading data via OPC UA or something on the network and losing information because the network's overloaded or anything. None of that stuff. This is running right on the hardware, captures data in real time. So it's basically like having your own digital storage scope, except you don't need to make sure the batteries are charged and you don't need to hook up the leads. It's a really nice debugging tool. Next, we talk about the built-in alarm manager. And at the end of that, we talk about object-oriented alarming. There's a video on that I would highly recommend. Just Google object-oriented alarming. You'll see my video. In the next chapter, Codesys does offer some add-ons to the IDE and a subscription, an annual subscription. So if you're coming from the IT side and you're used to programming in UML, they've got the UML editors there for you. They've got Subversion and Git for doing collaborative design and revision control. Got a static analyzer for finding potential issues in your code. It's got a profiler for wringing out the absolute positive maximum performance from your code. And it's got a test manager for managing all your tests. Next, we talk about the Codesys store and highlight some of the more noteworthy libraries and examples available on that store. The next chapter is the miscellaneous chapter. It's kind of like the kitchen sink of the book. Everything that goes here that didn't fit somewhere else. So like, for instance, the details and pitfalls of an online change and the cool features that Codesys provides to mitigate those potential pitfalls. And the last chapter is a full-blown object-oriented programming. So earlier we talked about the OOIP, which is a subset of OOP. This is a full-blown OOP. Codesys fully supports a full-blown object-oriented programming. So again, if you're coming down from the IT side and you're a proficient C++ programmer and you want to continue that programming technique within Codesys, you certainly can do that. So this chapter discusses inheritance and methods and properties and interfaces, pointers, all the potential pitfalls of pointers and how to mitigate those. It also talks about the difference between the traditional scanned programming that we're normally used to using and event-driven programming. And finally, at the very end, we have a final project, and this is designing a bottling plant. So this has a dozen or so different levels of achievement that you can shoot for, from a simple just fill the bottle and be done, all the way up to having a full process plant behind the bottling plant that's creating the concoction in a continuous process and then filling each bottle. And I mentioned, that almost every chapter has a lab at the end of it, and the lab has written instructions as well as screenshots of all the button pressing that's necessary to carry out those functions. So, if you don't remember, oh geez, where is that button? I can't remember. You just look ahead and to the screenshots, and it makes it very easy to understand. So I'm really happy the book's been very well received. It's you can buy it on Amazon, and it's got a perfect 5-star rating so far, and lots of great accolades. For those of you in the audio-only world, this is what PLC programmers have been waiting for! The best resource for Codesys so far. Take your programming skill to the next level. This textbook/manual is over the top awesome! It's almost like sitting in one of Gary's training classes. The only Codesys book you will ever need. A must-have! The best book of Codesys I ever had, and absolutely recommended, meets all my expectations and even more. So I appreciate those. The book is actually available in 2 forms. The 492-page single volume set that we showed you earlier. This is available from Amazon or directly from me. Go to bookofcodesys.com and it'll describe how to do those. This is also supposed to be available internationally on Amazon. So, I noticed it did show up in the German Amazon. Sometimes it disappears and sometimes it comes back. I don't quite understand all that. But if you can't find it on Amazon, there is a 2-volume set. The problem is the 1-volume book exceeds some limitations on international distribution. So I had to split the book into two to work around that problem. So international distribution, unfortunately, international distribution has a huge markup. So the single volume book is always going to be the most cost effective if you can get it in your market area. The content between the two books is identical. The technical content is identical. I have a few videos I would highly recommend. I mentioned earlier, just Google or DuckDuckGo Object-Oriented Industrial Programming, and you'll find a few of my videos. I highly recommend the one that says Object-Oriented Industrial Programming - Simulation and Configuration. That's probably the best single video. If you only got time to watch one, watch that one. It's 33 minutes, but it actually goes real well if you change it to 1.5 speed. So it takes a little less time that way to watch it. It really shows the power of object-oriented industrial programming and what can be done with Codesys. There's also a video that provides more information on OOIP. It's from a tech talk that I did for Codesys last year, so that one might be of interest also. And actually, I'd recommend all my videos. There's a playlist. Just go to YouTube, look for Gary_Hartland, and there's a playlist of all my videos. And while they're there, I would really appreciate it if you just press that subscribe button. All right, so and finally, check out the OOIP-foundation.org. So this is a clearinghouse for sharing OOIP objects. So the deal is if you download and benefit from some of these objects, you upload objects that you create. You pay back by contributing. So in time, the more we do that, we'll have a fantastic library of free open source OOIP objects for everyone to use. And that's about it. Shawn, I'll turn it back to you. Except for your questions.
Well, and I apologize. I had to turn off my mic. I had some noise in the background, but I really want to thank you for coming on the podcast. And just to let the listeners know, we're going to try to get all those links and put them into the description, so you'll be able to get to Gary's site, Gary's book, and the other videos he mentioned, his channel and whatnot. So we'll work on getting all of that into the description. So no matter where you're consuming the podcast, you'll have access to that. But Gary, I really appreciate you going through there. And I want to stress to the audience that, when you learn 61131, you're expanding your knowledge of programmable controllers. This 61131, whether you use an Allen Bradley Siemens or a Codesys-based PLC, a timer is a timer, right? And a sequencer is a sequencer. So there may be differences between PLCs a little bit, but the concepts are all the same. How you control machines, how do you control processes, this is all the same. So even if you're not ready to jump into Codesys, this is a great resource to have on your shelf because it's really talking about industrial control. So I just wanted to throw in, that's my 2 cents. But Gary, thank you so much for coming on the podcast. Is there anything else you wanted to cover before we close out the show?
No, I think I've covered everything.
Well, that was excellent. I really appreciate you putting that together. And I think that will give the audience a great idea of what's in the book and really the detail you went into, taking your years and years and decades of knowledge of not only programming the systems, but training people on them into this 400 plus page book, which is just a phenomenal book. And thank you again for coming on the show.
My pleasure. Thanks for having me.
Well, I hope you enjoyed that episode. I want to thank Gary for taking time out of his busy schedule to come on the show and walk us through his brand new book, The Book of Codesys. With that said, if you did enjoy the show, please give us a like and a sub. And if you're listening to the audio-only edition, please consider giving us a 5-star review. It really helps us reach a wider audience and find new vendors to come on the show. And I really want to thank those who have already done so. I noticed that we have a few more 5.0 reviews there, and just want to thank you very much for doing that. Now, if you'd like to follow me, as well as optionally support our show, you can do so over at automation.locals.com. And of course, you'll always find all of my training courses at theautomationschool.com. With that said, I want to wish you a very happy, safe, and healthy week. And until next time, my friends, peace.